A very good afternoon to all of you. Uh, as Sir has already introduced me, my name is Sandeep Bhardwaj, and I'm working in the field of CNC machines, which are the most latest technologies they have in today. And further, I'm associated with the CAD/CAM industry since last 20 years now. And today we will be covering a session which is a very latest technology uh, uh, already adopted by most of the institutes in India, and largely they are being used in the research level. The technology which is known as micro hybrid machining center. So I will be covering that. So today topic will be hybrid micro machining technology. So this is the agenda. We will be covering all these aspects, like what is micro manufacturing and why hybrid micro manufacturing is required. And we will be covering the construction of a unique micro machining center, which is a patent product. And we will be covering the illustration and benefit of hybrid processes. I'll definitely show some samples which we have already made out of that, and largely the application areas in industry and in education side both. And there are some accessories required as a add-on. And finally, a very brief introduction of our company, Mikrotools. It is basically a Singapore-based company, and they are the founder of this machine. So, what is micro machining? This is basically a scientific definition of micro machining. Micro machining is a general term used to indicate a collective form of all the process technologies used for machining of microstructures and microsystems. So this is only a basic scientific, we can say, definition of this micro machining. But as of now, like everybody can recognize what is it. So in our daily life, we are utilizing each and everything which are, the most of the thing which are made of the micro. This is a small, example of micro manufacturing, a ballpoint pen. I hope everybody recognized. So now we are talking about micro level products which are being used in and around our daily life. So this is a product which falls under 400 to 800 microns, right? I hope everybody recognize this. No, it is a medical syringe which falls under 350 to 750 microns, and already being manufactured since a long time now, right? So nature is one of the best engineer. So this is the human hair, which falls under 70 microns, and somebody have maybe a larger diameter to that. And this is MEMS devices. Now we are talking in dimensions. It falls around 10 microns and above. I hope everybody have at least one device with them, whether it is a mobile phone or a laptop. So each and every device, they have at least one MES devices into that. So in a medical, further, we are talking about further less than 10 microns now. So now level which I am going to introduce a product or a technology or a manufacturing capabilities to you, which falls under this kind of dimensions. So it is a RBC, and you may be able to see, you can make a hole using this latest technology through which a single RBC can pass through. So micro machining is what, like, have you ever actually produced a micro machine part? This is the biggest question arise. In my career in last 20 years, I have seen a very less industries which have micro machining capabilities. They might have a single source of, uh, a single machine. It can be a single turning machine or a milling machine, or somewhat of a hybrid technology of turning and milling both. But when actually we talk about a micro hybrid machining center or micro hybrid manufacturing, very few of the companies or the institutes even they are using some technology into this. Why is this question arising? We will illustrate what is the is already taken into the agenda. So I'll let you know a few things about non-conventional micro machining processes, which are already available into the industry. And as I already said, MEMS devices are being manufactured. They are already being used, these kind of non-conventional micro machining processes. So photolithography on a silicon substrate, deep X-ray lithography, LIGA process in short form, and focused ion beam machining. All of these categories of manufacturing processes falls under micro machining, but they have biggest disadvantages. The main disadvantages is they are very lengthy processes. For each and every process, you need to develop a mold or a scalp, which is not easy to do that. You can easily find out the detail of each and every process. You can Google it, but I'm giving you in very short definition. Like the major disadvantage is we cannot make a pure three-dimensional structure using these kind of processes, like, and the very low aspect ratio, and there is a limitation of the workpiece material, and the further they are very expensive to utilize. Maybe if talk about a single source of this kind of non-conventional machining, they can go beyond 5 crores or so. So it's very difficult to manage that. So the second part is tool-based machining processes, which are the basic mechanical and electrical processes we can follow. So micro turning falls under that, micro grinding falls under that. They are the mechanical processes. Micro EDM, I hope everybody recognize the EDM, because 20 years back it was difficult to find a EDM machine in India, but now everyone is using the EDM machine. So wire cut EDM is available and wire EDG is also available. They are following the electrical processes. So what are the advantages is already mentioned, is less limitation of workpiece material, high material removal rate, and flexibility in 3D feature shapes. So we can easily make a electrode or a 3D electrode or any profile electrode, and we can utilize it using a die sinking method, using EDM machine. And the high aspect ratio we can check, and capable of machining hard materials also. Even a tungsten material can be machined using this kind of, and the very low cost setups. They are not much expensive processes. So we have three kind of, largely we have two kind of multi-process machine technologies. One is a large conventional machine and other one is a ultra precision machines, right? But we are talking about a miniature multi-process machine tool, which falls within the both categories, and they have the major advantage for the micro machining. Using large conventional machines, they have some issues like mechanical and thermal deformation. You cannot avoid chatter, vibration, tooling, and clamping errors. Like even you are using any kind of fixtures, occupying large space and higher power consumptions. They are not even suitable for the ultra precision parts. Now, on the other hand, like ultra precision machines, they are excellent motion accuracy, extremely expensive, and require regular maintenance, occupy large space, and higher power consumptions. Mostly not suitable for the hybrid processes. As I already told, if you want to use ultra precision machine for turning or milling, a single process you can utilize it. When we are talking about a hybrid machining, so number of setups should be very less, because if you try to change any tool or any fixture, you will not get the that kind of accuracy what is it is required into the micro machine. So as I already told, the miniature multiprocess machine has more advantage for that. They have higher accuracy, less number of setups. On a single setup, you can, without changing a tool, or you can create a tool itself on the machine and utilize it. You can manufacture a tool using a turning technology and utilize the same tool for doing as an electrode for the die sinking. So less number of setup, minimum idle time, significant reduction in investments, reduced power consumption, and required floor space. They are very compact. So minimize thermal expansion as well. Advanced sensors and instrumentation for superior positional accuracy are being utilized. Fast mechanical response time they have, and flexible of hybrid micron fabrication is also advantage for that. So, what exactly is micro machining? So, we are talking about a hybrid micro machine tool, which is already available in the industry, and mostly in the research institutes like IITs and IITs. It is already being available now. What it does basically, it is a single source of machine. It's a single source of setup which can run a micro turning, micro milling, micro drilling, micro EDM milling, micro EDM drilling, micro wire EDM, and micro wire EDG, and micro reverse EDM also. And now the latest innovation into this product is uh, they had incorporated the laser technology also, which was earlier not available. So they had already introduced the laser technology, and that product is already being delivered in IIT Ropar. Recently, we have delivered that product and being installed. So IIT Ropar is a single institute. They have this integrated laser technology available into that. So hybrid micro machining tool has a capability of 3 axis continuous CNC fully closed loop. So just like a standard state of art conventional machine, a fully closed loop feedback makes precise motion control feedback possible. Like we can work on a very precise level. So on machine measurement, we can mount a 60x camera on the machine itself, through which we can digitize, we can measure, and we can record what is happening on the machine, like the cutting and each and everything. It can be recorded, right? And the positional accuracy of this machine is plus minus 1 micron per 100 mm. Getting the accuracy is not a big deal, but carrying it on certain length, it is the biggest issue. So up to 100 mm, you can get accuracy of plus minus 1 micron out of this machine. Normal conventional machines, if you talk about a simple CNC like milling or turning machine, they work under the accuracy of 25 to 100 microns. So this is a kind of difference you can check. So resolution is 100 nanomicron. Electrically isolated spindle. As I already told you that you can make your electrode using the other uh, machining processes like turning and milling, and the same without unmounting that workpiece, you can use it as a electrode for the EDM purpose. So this isolated spindle is basically a patent product, which is a research has been done in Singapore University. So this is our core base of this research. And spark control mechanism is already there, and it is a very modular design. It looks like a simple any you can check the kind of close and closer, having a control panel on it. You can create your own program, NC program, and you can transfer that program through using any RS-232 or RJ45 connectivity. And even you can utilize your pen drive also. You can use any CAM software. You can create a program, whether it is a turning or whether it is a milling, and you can transfer it to, right? And a spindle with negligible run out, because this has to be done, otherwise the accuracy cannot be managed. So this is the world's first hybrid micro EDM, and the product name is DT110i. And it's a very the design is very simple way. Why I'm showing you this, because this is a kind of technology which will give you a bigger scope of the research. The people they are using, the founder, who is the founder of this machine, has already published more than 600 papers. He has already published this more than 600 papers out of it. Little bit about the construction of this machine is basically uh, it's a natural granite table is being used for the base, and the y-axis module is mounted on the granite base, and x and z axis are mounted on gantry type cast iron structure, which is also mounted on granite base. And the XYZ travel of this machine is 200 by 100 and 100 mm, because we were talking about a micro machine, micro manufacturing. So the table size is not a bigger. As you can see, can I- see, this is a microscope or a camera can be mounted on this machine, and this tank can be utilized for the EDM part as well. And anytime it can be, unmounted from the table. And the best part is only a single screw is being, utilized to mount and unmount any kind of structure out of it. Oh, okay. So, why and how this micro machining research has been done? It is a very great story behind it. I'm just sharing with you, because the the founder or the innovator is already from research institute. So I hope everybody recognize Panasonic. Long back in mid 90s, Panasonic is looking for manufacturing support to manufacturing 40 micron electrode. They required it for some of their manufacturing purpose. Actually, they have to make a hole of 50 microns. So for that, they are looking for a support to make a electrode of 40 microns in the mid 90s. Professor Rahman is the founder of this company, Mikrotools, and he's an innovator of this micro machine. He was there in Japan at that time, and he has been called for the support. And what was the current setup of the Panasonic? They were using different machining machines, right? So for making this electrode, they are using three machines to do it currently. The first dressing electrode to 40 microns using EDG and measuring 40 micron on CMM. And finally making the hole using EDM die sinking. And the average time they were taking is around 8 hours to do one hole basically. The reason being the handling errors. Imagine handling something half the diameter of hair. It is it's not easy task. So they wanted to make many holes for that. So they have been called upon Professor Rahman, and Professor Rahman has taken up the initiative, and he said, "Okay, I'll do that. Why not? It can be done." So that kind of challenge he has taken, and the challenge is making a diameter of 15 micron hole on a SS sheet. So that was a challenge. So EDM die sinking tool requirement, electrode of diameter 45 micron is required. So initially available workpiece were brass, 4 dia and 6 centimeter long. So approach has been taken is micro turning workpiece and EDM die sinking. So this approach they had decided to go through. So step one was the diameter reduction to 100 micron using micro turning, and step two was further diameter reduction to 50 microns. So that, so what was the challenge? The why turning of shaft below 100 micron is so difficult? Because the most serious problem, cutting force. So it has, as you see, the two components. So they tried, and they calculated each and everything, and so this shaft has been created the below 100 microns. So they have observing all the cutting force parameter by taking the consideration deflection and stress equations. They tried varying all the possible parameters so that the lowest possible deflection and stress are achieved in hope to achieve shaft below 100 microns. But the problem persists. Their research then led them to paper on micro turning by a German professor who suggested that step turning can be utilized to desired diameter. So now they have two type of tool path. The path A is a regular type of path. To It's a regular type of turning used in turning, CNC turning, and the path B is a step turning. So they utilized the step path B, because in path B this is a step cutting, and this method is a very small length of cut is chosen, maybe 50 microns. Then a similar depth of cut is chosen. Now first cut can be 50 micron and the length of 50 microns, and second cut is the same length but depth can be vary for 100 microns. So using this, surprisingly, this process yield amazing result, and diameter of up to 60 micron were being achieved. As step size reduced, the deflection and step error reduced. So easily you can check out through this equation. So now we have a shaft of diameter of 50 micron. As earlier we have a 100 micron shaft. But remember, correct, our aim was to make a electrode of diameter 40 micron. So step turning also 60 micron was achieved. This time professor said, why don't we eliminate cause of deflection, the radial force on workpiece. So when vertical turning happens on the machine, in an ideal world, the radial force exerted on the workpiece by tool should be zero, and only thrust force in axial direction should be there, as shearing and chip removal happens. So, so the idea of using a cutting tool with sharp tip arise, and they further achieved the lesser diameter. So they utilize the solution again laid in the machine built as it was capable of micro EDG, the operation as well. The PCD is constructed with cobalt, with being electrically conductive makes EDG possible. So the team did the EDG machining and fabricated the modified PCD cutter of diameter of 5 microns. So we were talking about the 40 micron, 45 microns, and now we have achieved the 5 microns. So this is the step of micro turning processes they have utilized. Earlier, the diameter is for the 4 millimeter, and the final shaft has been achieved. So micro turning capabilities, if you check a hair of below, and a 11 micron graphite shaft is being manufactured using this technology. Further, these are the practical photographs has been taken after manufacturing. All the steps using 5 micron shaft, EDM was done, and the world's smallest hole using micro EDM was fabricated on the same machine of just 6.5 microns. So machining a 50 micron hole initial electrode dimension 4 mm and 6 mm. And this was the difference. The tool set up in conventional EDM already explained, and tool setup in hybrid micro EDM, because on the same setup we had manufacture a tool, and the errors are very less, and this spindle of workpiece placed within the EDM tank without removing the electrode, because the same table is being utilized. So the question may arise, why combine micro EDM with micro turning? So micro turning can offer fast re-preparation of tools, better rigidity, no reclamping errors. So this is the major benefit we can get over there. So this is really a micro hybrid machining. We are not only talking about a micro machining processes, but we are more keen to talking about the micro hybrid machining setups. So I hope importance of hybrid processes of micro machining are understood. Now there are many other processes possible due to. So these are some samples which has been made using micro milling. Micro fins of 70 micron thickness. Sorry, I think some error of font is there. Sorry, it's a micron. That symbol has to be micron. Some font error is there. Sorry, it's used for, like, the different kind of industries. This is more like of an impeller type of product. Can be utilized in the aerospace industries as well. It's very small. It's very small. Yeah. See, I'll be sharing what kind of application can be utilized using this kind of technology. Yeah. It has been made as a sample in the medical industry being utilized. See the next part, the very small fins being manufactured using the same technology. It's a micro milling. This is what we are talking about, the smallest holes. So, so this after the development of this micro machining process, so these kind of processes can be uh, done. I think it is not visible over there, right? So micro EDM die sinking can be done. Micro milling, as already taken. Micro reverse EDM is like I'll show you some example of that. This is a reverse EDM can be done. It is a patent technology of Mikrotools, and it is understood that finishing operations are really possible. Hence, our EDM itself is designed to generate the highest quality finish and the dimensional accuracy. As I already explained, the process of making electrode and utilizing it on a workpiece. The similar way it has been shown. The first specification of electrode can be, utilized, and further the same spindle is working for the EDM part. So this is a technology which is available. This is micro wire electrical discharge machining attachment, which can be mounted on this machine and as a separate attachment to itself. The spindle itself is removed from the Z axis and the wire EDG picture can be added. This is a different from conventional wire EDG because the diameter of wire is very small. So normally diameters are being utilized more than 200 microns and above. But here we are utilizing 30 to 70 micron diameter of the wire. So this is the another attachment. So there are more sample for this CDM machine. It's micro wall slot. This is another sample. This is the reverse EDM, which I already told you. Earlier we need electrode to make a hole, and this is the reverse process. So what are the major application areas? In aerospace, for the turbine parts, fuel injectors, calibration tools, the micro machining has been done. And for making a micro molds, this technology can be utilized. And the medical, they are very large, vast field area to manufacture a lot of components. Uh, and even in electronics and microelectronics. And for the academic part, the internal research purpose, it can be utilized, and consultancy and fabrication job purpose can be fulfilled. Yeah, the more applications. You see the dental orthodontic spring with a nickel and titanium material. And the textile, the micros spinneret and micro nozzle of various dimensions. And as I said, the micro mold can be manufactured. So I can directly take to you the working model of this machine. I will show some video. As I told you, this is the camera mounted on the machine, and all the pictures has been taken through this only, and we can record it uh, through live machining as well. Otherwise, it's very difficult to check what is happening on the machine because very micro level. So as you see, the electrode has been made, and the similar electrode is being used for the EDM purpose. So this is a laser technology which has been integrated very recently because some of the customer they required a fastest technology method. So this laser has been incorporated very recently, and these are the parameter of the laser technology: extremely high cutting speed, high depth of cut, and highly material versatility. And disadvantage maybe requires subsequent finishing because of the laser cutting. We may need to be some post machining or finishing operation may be required. And we can utilize spindle speed between the range of 10,000 to 60,000 RPM. We can utilize uh, in a normal in industry. If you talk about CNC machines, so the availability of spindle speed is around 8,000, 10,000, and which are easily available. But we can work out up to the 60,000 RPM. So more the RPM, more the finishing can be achieved. And the dynamometer is all can be mounted on the machine to measure the micro forces. And we have a vibration device also, and ultrasonic cleaning device can be utilized. So this is all about the technology which we have available, and a lot of institutes are using this technology, and a lot of research papers are being published using this technology. And about Mikrotools is basically a Singapore-based company, and it is a spun out of a national university of Singapore, because Dr. Professor Rahman is the founder, and he is still a professor over there in Singapore University. And they are the developer of micro and nano precision machine tools, and which are research oriented, and they have patent technologies, pioneer of hybrid micro EDM machine tool technologies. And they have global presence, Singapore, Malaysia, and globally they have already sold out a lot of machines, and mostly they are using into research purpose. This is the latest model of the machine. In video, you must have seen older structure than the enclosure. This is the latest structure of this machine. And there are two machines. One is hybrid micro machining center, and the second one is ultra precision diamond turning lathe. But this is an independent machine for turning purpose only. It is a lathe. More about this hybrid machining center. As I said, we are using a very user interface. It's a very user friendly interface we are utilizing. Uh, I hope most of the people out of you are aware about the CNC machines. The basic part is when we mount any workpiece on the machine, we need to give a reference to the machine. So we have to decide the machining coordinate system, because any machine, any CNC machine, uh, they have their own home position, and we need to define the machining coordinate system as per the workpiece. So in this machining center, it has been done in a very easy way, and the sensors are being utilized, and on a single button you can define the MCS and to start the machining activities, whether it is a milling, turning, or any kind of etc. So it is very easy. You can make a program. You can make a program and run immediately. So this is the EDM power supply integrated into the system. Before I conclude, if you have any question, I think so. This is a spark laser technology which has been incorporated recently. Change? Can you change? Sorry. This is the added feature. Recently, as I already told, we have supplied this to sorry, IIT Roper recently. Last month. Yes, 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 yes. You need to change the head, the spindle part, and you have to replace it with the laser technology. And a lot of other things need to be required. So it is, yeah, it's recently it has been done, especially for the IT. But now it is already incorporated and it is available.
This in the subsidies is mainly for this testing purposes. For this.
No, no, no. Already they're using for. It is not a for the production side. You can say it's for the production side because it is a micro, and we need more patience to manufacture a single part for that. But yes, for the research part, a lot of things. People, most of the research recently in IIT Kharagpur, someone has developed a new material which is anti-slip. Yeah, it's anti-slip material. He had done his research using this machine. In IIT Ropar, they are utilizing it for the forming part. So microforming, they are utilizing this machine. So there are endless. Yes, if you go and Google Doctor Professor Rahman, they have his own blog available on. I can share the information. Just write down Microtools and Professor Rahman. That's it. You will find out his blog. All the research paper and whatever he has published, each and everything is available. Yeah, yeah, yeah. Professor Rahman. Yeah. He's an Indian origin, but he's been settled in Singapore now. He's still a professor at Singapore University. He come once in a year in India, but at that time, I think recently he's coming in uh, NIT Jalandhar. There's a international level conference is being organized. So he's a key presenter over there.